All right, so last lesson we talked about measures of center. What were those? Mean, median, mode. Good. Today we're going to talk about measures of spread. That's going to include range and standard deviation. We're also going to learn about a normal curve. So variation is just anything that has to do with how the data is spread out. The first one that we know is range. Range is always your max minus your min value. So you're going to take your largest minus the smallest, and you will end up getting one number. So don't say that the data ranges from 5 to 10. That would be 10 minus 5, which is 5. The range is not resistant. Do you remember talking about that last class? What does the word resistant mean?
It's
Not affected by outliers. And what last class was not affected by outliers? The median or the mean? Median. The mean was affected by outliers. In this case, the range is also affected by outliers, because if I have a really low data point, that's going to make my range larger than if it weren't as low. So it says that it is not resistant, which means resistant means it's not affected by outliers, but it is not resistant. So the range is affected by outliers. If that will help you, I'm just going to write is affected by outliers. The next one is standard deviation. Standard deviation, we are going to use the calculator. So you're going to see a few formulas that you don't need to memorize because the calculator is going to tell us all of them. But standard deviation is a little bit more precise than spread because the range is simply just the max minus the min. The standard deviation looks at the frequencies among the entire set of data. So if you need a calculator, there are some over there. You can grab them. Make sure to take the same one that you did from last class because we're going to be putting in data into a list.
So where's number? Oh, the same type.
Mm-hmm. So if we look at the example, we have set 1. If I were to graph set 1, like if I were to make it into a dot plot or something for set 1, here's 100. I would have 1, 2, 3, 4, 5 data points that are all 100. So my standard deviation would be 0 because nothing deviates from the mean. Another definition of standard deviation is the average distance from the mean. Like how far things typically deviate from the mean. Just by looking at a picture, you can decide which one has a larger or smaller standard deviation, but the calculator will actually do the work for us.
And that is affected by outliers?
Yes. So this is set 1. Set 2, it's going to look something more like this, where you've got 90, 100, and 110. You have 2 data points at each. So the average distance from the center is about 10. Whereas in set 1, there's nothing. They're all in the center. There is no deviation from the mean.
Is there like a formula for that, or you just like guess?
So the formula is here, but the calculator is going to do it for us. So you do not need to have these memorized, okay? The only thing that I do want you to notice is that the population standard deviation is called sigma, which is the lowercase Greek s. So that goes with population. And sample is the English letter S. So if you remember, the mean What was the population mean symbol? The MW thing. What was the sample mean? X bar. Good. So sample always has the English alphabet, and population has the Greek. So just keeping up with the notation. Population standard deviation is going to be sigma, which is a lowercase s, kind of looks like an O, and then sample is going to be s. You do not need to have these formulas memorized because the calculator will provide. And I'm going to show you in a minute how to do that. Here are some important properties of the standard deviation. Once again, we did say it's how far it deviates from the mean. The standard deviation can never be negative. And why do you think that that is? Why can you never have a negative?
Because that's not a negative distance.
Yeah, you cannot have a negative distance. Larger values of standard deviation indicate greater amounts of variation. And outliers can drastically change, so that also means that it's not resistant. So I'm going to give you two examples of sets of data that have the same range, so out to the side. Here are two distributions, and let's say that they both go from 1 to 10. If I had a dot plot that looked something like this, and I had a dot plot that looked something like this. So in the first set of data, most of it's in the center, and in the second one, it's more spread out on the sides. Even though they both have the same range, if I were looking at it, I wouldn't know the exact numbers, but I could say that the top one has a smaller standard deviation and the bottom one has a larger, because they both have a center in the middle at like 5. There's more distance from the mean in the second set. There's less distance in the middle set. So you should be able to look at distributions and decide which one is larger and smaller standard deviations. The next symbols, or the next notation, is called variance. The only thing you need to know about variance is that it is the standard deviation squared. So it's sigma squared and s squared. You don't need these formulas because the calculator will provide. I'm going to write that again. So the only thing that you need to know, if it asks for variance, you're just going to take your standard deviation and you're going to square it. If it gives you the variance and it wants standard deviation, you just square root it. Pretty simple. These are showing you how to do it by hand. I want you to, let's see, what is it wanting you to do? I think that it's telling you how to do everything by hand, but we do not need to know how to do it by hand because the calculator will provide.
Yes, calculator.
The calculator will provide. So let's put these scores into a list on our calculator. So if you want to put data points in a calculator, you will go to Stat, Edit, and then in List 1, just type all of the scores. from here, you want to do one variable statistic. So I'm going to go to stat, calc, enter. Keep the list as L1. You don't need a frequency list and hit calculate.
Oh, I see the little sign.
So from here are the things that we need. X bar is our sample mean.
So do we...
X bar. It is also your population mean. They both are the same thing, the way that it's calculated. So if the question were asking me for the mean, if you look at the context of the question, is it a population or sample? That's not a yes or no question.
Population.
Because why?
It's the whole class.
It's the whole class. So it's the whole class, so I'm going to say mu equals 79. I think we did this in the first lesson. We don't need this. We don't need this. Now, these two numbers right here, you have to decide which one to use. SX is my sample.
Oh.
Yes. So the sigma x is population. So I'm going to say, I just make a little curly O, kind of. 9.818. I'm going to go out 3 decimal places.
So should we do that for every
That's
time?
the population standard deviation.
So
Okay, everyone listen. You're not looking. On your graph, or on your set of data, whenever you output the 1 var stats, it's going to give you sample and population mean, and you have to choose which one to do. So when you do your assignment, it's going to ask you for one or the other. You have to decide which one to use. If it's a sample, it's S. If it's population, then it's sigma. Yes?
do we always go 3 decimal places? When do we...
If it's my math lab, it'll tell you what to do.
Okay.
Sometimes just 2. For me, do 3. N is your sample size. Then you have your minimum, your Q1, your median, your Q3, and your max. We haven't really talked about those numbers yet, but we will. I think all we've learned so far is the median. The next thing that it's asking for is the range. So I can use my min and max. Range is just 94 minus 62. So 32. And then the last thing that it asks me for is the variance. It doesn't give me variance on this. I actually have to square the standard deviation myself. So I'm going to take 9.818 and I'm going to square it. So go ahead and do that in your calculator and tell me what you get. What do you get? 86.39 what? 96. I heard 86. 96 point what? 393. Good. So when we talk about mean and standard deviation, they can be applied to what we call a normal curve. If you've ever heard anything like that this is on a bell curve, or if you take the SAT and you get a standardized score, any standardized test, you are just a little dot on this curve right here. One of these is you. You are. But you are significant, but you are one of these people on this. So if you ever get a percentile, like you're in the 70th percentile on this test on the SAT or on the ACT, it means that you are at the 70th percentile. You did better than 70% of the people that took it. So you're on a place on this curve. And the reason why they create a bell curve or a normal score is so that you have high frequency in the middle with outliers on either end. So you want most people to do at a certain average, and then you want outliers on the top and on the bottom. So on a normal curve, I also have a pillow. Ashley, will you grab the green pillow? And yeah, that's what these are for. This one.
Can you catch it?
I can.
All right.
Thank you. This is my normal curve right here. This is normal. So cute, little plushie. On Etsy. No Etsy.
Someone makes these and sells
Yes.
So did you actually like go out looking for statistics?
Yes. I did. I did.
If I ever... Never mind, I'm not going to say that.
That's dedication.
Yes, so this is the first of all of the ones that we will begin to learn. So this is the normal curve. If you forget about it, remember this pillow. The first thing we're going to learn about the normal curve is that it is centered at the mean. So it is centered at the mean. Centered at the mean, which we call mu. In this case, we are going to say that the mean is 0. So, in this case, the mean is 0. Then you're going to go out 3 standard deviations on each side. So we're going to go up 3 standard deviations, down 3 standard deviations. So 1, 2, 3, 1, 2, 3. And in this case, the numbers you see here, the standard deviation is 1. So we're going to go up 1, 2, 3, down 1, 2, 3. Because of 1, 2, 3, negative 1, negative 2, negative 3. So when you're so we're just saying for this normal curve, it's centered at 0. The standard deviation is 1. So you're going to go up 1, up 2, up 3, down 1, down 2, down 3. Draw a bell curve. To make it in a completely normal distribution, that means that it has to follow 3 guidelines. The first is that if you go out plus or minus 1 standard deviation, that contains 68% of the data. So of the people that took the SAT, 68% fall within 1 standard deviation, up 1 or down 1. If you go out 2 standard deviations, that is 95%. So 95% contain the within 2 standard deviations, and then plus or minus 3 standard deviations is 99.7%. So virtually, if you go out 3 standard deviations, that virtually captures 99.7% of the data.
So, standard deviation is kind of more like a slope.
Standard deviation is your distance from the mean. So if I were to just kind of guess, what would you say, and this is not coming from any sort of information, I haven't looked it up, but what would you say that the average ACT score is?
22.
22, 21? Let's say 22. What's the highest that you can get?
I think it's 36.
36? Okay, and then what's the lowest you can get? I think. So let's say, just for example's sake, let's say that the average SAT score is a 22 and that the standard deviation is a 3. So that means I've got 22, 25, 28, 31. Then I've got 19, 16, 13. So I went up by my standard deviation 3 times. 1, 2, 3, down 1, 2, 3. I just randomly chose.
Okay, so on the bottom there, that's like a set of data.
Yeah.
Alright.
So based on the normal curve, that means 68% of the population make between a 19 to a 25, because I just went out 1 standard deviation. That seems about right. I don't know, I'm just making this up. But that's what this normal curve means. Also, that means 95% make between a what?
A 16 and
A 16 and a 28. And then lastly, that means 99.7% make between a 13 and a 31. Then you've got outliers on the top end and the bottom end. I would say that you do need to memorize this curve. Even these numbers like this 34 and 34, that just cuts that in half. Okay, just cut the 68 in half. The 13.5, 13.5.
I have to memorize that?
Yeah.
Okay.
So it's always like 68.
But you can rebuild it. If you know 68, 95, 99.7, you can build in the other. And like when you start your test, I would just say at the top of the page, draw your normal curve and go ahead and build it in. Then you can reference it.
So it's always 68, 95,
Uh-huh.
99.
Yes.
Like, in general, like, you're not gonna change it?
No. It's always that.
Okay.
Okay. For this, I want you to, so you're sitting at a table. I want each one of you to take A, B, C, or D.
I got C.
And we're going to find out, you're just typing in the list of data, find out the sample and population standard deviation. Okay, so the main thing is just looking for whether it is sample or population. So you want the range, you want the sample standard deviation, and you want the sample variance. What do we get for variance? This is what you should, well, what do we get for range? I didn't calculate it.
1120.
1062.
That's not what I got.
Is this your standard deviation?
I got 1120.
Is that right for standard deviation? Okay, what do you get for variance?
Range is 1120. It's okay.
Oh, range is wrong?
Oh, wait,
Yeah.
1120. Oh.
Yeah.
Okay, variance.
351. 601.569.
Y'all are awful.
That's what I got.
Okay.
Oh, 562. If you want to write that.
But it is money.
But it did not give me that.
I'm going to show you the normal curve way first.
Wait, is this by hand?
Yes, so we have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. So here is my picture. Everyone is going to draw their picture. They're going to put 100 in the middle. And then standard deviation of 15. So I'm going to go up in increments of 15 3 times. 115, 130, 145. Go down 3 times. 85, 70, 55.
Why is it 3 times? Is that like the rule?
Yes, so this is, because it says bell-shaped. That means we're using a normal curve.
No, but I'm saying like you always go like 3 increments.
Uh-huh.
3
3 up, 3 down.
on bell curve.
Yes.
Is it different on different kinds of shapes? No.
Well, it's always, this is the only one that we use it for. From here, we know that this is 68, 95, 99.7. From here, you can then build in the little parts. So I'm going to break up the 68 to be 34 and 34. What could my next 2 columns be? You can either look at the picture for reference, or how could I figure that out?
You take 95 and subtract 68.
And then divide by 2. Then take 99.7 minus 95, divide by 2. Point what?
1.5.
For sure it's not 2.5?
That was 2.35.
It's 2.35.
Where were you getting the 2.15?
That's on the outside. Yes. So you should be able to build this on the test, on the quiz. Okay? Then it says, what percentage of people have an IQ between 70 and 130? Well, now the hard part is over. I'm just going to add them together. So between 70 and 130 is 2 standard deviations out. That's 95%. Greater than 130. So everything above 130. I'm going to add the 2.35 and the 0.15. What percentage of people have an IQ between 55 and 115? So I'm going to look at 3 standard deviations below and 1 above. So 68 plus 13.5 plus 2.5 plus 13.5.
Wait, why is it 2.5 instead of 2.35?
2.35 is 0.15.
Oh, 2.35, you're right.
Well, it's the same, right?
No, because 2.5.
Because I'm just going from 55 to 115. So I'm adding these up. So 68, 13.5, 2.35. Good. Okay, I'm going to show you how to do it in the calculator. My only hesitation is I'm not sure if MyMathLab will, because it makes it very, very exact. So I'm going to see if MyMathLab accepts it. But I'm going to show you this way too, and then we'll figure it out. So if I wanted to do this in the calculator, I'm going to go to, if I want to figure out like the answer to number 1, A, it says what percentage of people are between 70 and 130. I'm going to go to the second button, VARS. Second VARS. VARS is right here. Second VARS. I'm going to go down to normal CDF. Second VARS, normal CDF. Then it's going to have a lower and upper. It's going to prompt you for a lower and upper. Lower bound, upper bound. It says between 70 and 130. So I'm going to type in 70, 130. Then it asks for my mean, which is 100. And my standard deviation is 15.
Do we press enter?
Press enter, enter. 0.9544. So 95%, 0.95. That was the answer to A. Next one, it says greater than 130. So, whoops. Second VARS. Why do I keep doing that? Second VARS, normal CDF. Greater than 130. My lower bound is going to be 130. My upper bound now needs to be infinity because it's greater than that. So anything infinity, I'm going to say 2, then this caret, the 99. That's just going to be my infinity. It's a really, 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 really big number. Okay? Then keep 115. So that it's a little bit,
2.27.
yes, 2.27%. So it's a little bit more exact, the calculator is, than the empirical rule. So that's why I hesitate in showing you this, just because on MyMathLab it may want the 2.35%. I would take either one. Then for C, between 55 and 115.
That's what I do to get my points back.